I'm Chris Gerdes, Professor Emeritus of Mechanical Engineering at Stanford University. Let's answer some questions from the internet. This is Automotive Support. At Donkey Delph asks, should I buy an EV now or wait a couple of years whilst they're still improving technology and prices come down? One thing you may want to think about is Ford has recently announced that they're going to use Tesla's charging system on their future electric vehicles. Tesla built the supercharger network specifically for their own cars, but other manufacturers have decided that that's actually a really good engineering option. And so they are engineering in the Tesla charging system into their cars. So if what's out there today meets your needs, go ahead and buy it. But if not, you probably don't have long to wait until something comes out that does. At Punicist wonders, I wonder why solar-powered cars aren't a thing yet. So if I take the Mercedes behind me, that's a really large car. I could fit maybe 4 solar panels. Each of those under peak conditions would produce about 400 watts. Put it together and I have 1,600 watts, almost enough to power this hair dryer, somewhere on the order of about 2 horsepower. All right, but maybe I could use this as an alternative to charging. That same amount of power would actually be less effective than plugging your electric car into a standard 120 volt wall outlet. It would really take forever to charge. So if you want a solar powered car, simply put solar panels on your roof, generate electricity, and use it to charge your electric car. At Alan Buxley asks, why isn't there a huge market to retrofit most popular petrol cars with battery packs and electric motors? So you can take a petrol car and turn it into an electric vehicle. My team and I did that with this DeLorean. In order to fit everything in, we actually had to design and fabricate our own subframe for the car to hold these new components. But this is not the easiest way to go about getting an electric car. You're going to spend a lot more time and money than you would simply buying an electric vehicle. The challenge is that your car was designed to have an engine and a gas tank. If you start to pull in electric vehicle components, there's a lot of things you have to ask, like how safe is that going to be in a crash? What have you done to the weight distribution of the car? So this is why you don't really see many electric vehicle retrofits out there. At the Ulterior Kid writes, how do self-driving cars see? Self-driving cars can use a range of different sensors. Radars can be very helpful sensing metallic objects that are near the car, but sometimes it's hard to tell exactly what that radar is bouncing off of. Cameras give a picture of the world that's not unlike what we see with our eyes, but it doesn't really give you distance information. Finally, LiDAR, or laser scanners, this is a series of beams of light that tells very precisely how far away an object is from the LiDAR. You'll see that the LiDAR is spinning on top of our X1 vehicle behind me right now, and it's painting a picture of me sitting here at this table. So if I move my arms, you can see the image move. Each one of these lines represents one of the spinning lasers. The color tells how intense of a reflection the laser is getting. So autonomous cars see by using a variety of sensors and AI to turn all of these sensor signals into a picture of the environment. At Kindman72657 asks, why do autonomous vehicles have steering wheels? Our federal motor vehicle safety standards are generally interpreted to mean that all cars have to have driver controls. It's easier for manufacturers to simply leave the steering wheels and driver controls in the cars. Engineers like to talk about levels of automation. A level 1 vehicle is a system with an adaptive cruise control, something that uses a radar to follow another vehicle safely, or a lane keeping system. A level 2 combines these two systems, but the driver needs to remain with their hands on the wheel. A level 3 autonomous vehicle, that's this Mercedes EQS here, that car will actually drive itself in limited conditions in traffic jams. The driver can take their hands off the wheel and their eyes off the road. A level 4 automated vehicle is a vehicle that can drive itself within a specified area. These driverless robotaxis that you see companies like Waymo or Cruise. Level 5 autonomous vehicle is really the highest level. That's a car that can drive from one point to any other point that you want. That car obviously won't need a steering wheel, but that's a long ways off in the future. At Kuchariot wonders, how will flying cars operate? There are several manufacturers out there looking at very light aircraft that could take off and land vertically and might travel electrically over 50 to 60 miles, looking a lot like bigger versions of the drones you may be flying. These aircraft could in fact operate autonomously. In some ways, that's an easier problem than trying to make a robotaxi. You don't have to worry about pedestrians or many other vehicles if you're flying fairly low over the ground. At Hazel asks, can anyone explain to me why Miatas are cool now? It's a Miata. They have a 50-50 weight distribution. When you turn your steering wheel, what you're trying to control is the yaw rate of the car, or how fast it's turning. In many cars, what you'll see is a yaw rate response that tends to oscillate. The car kind of wiggles as it's getting into its turning rate. But with a 50-50 weight balance, like the Miata has, the car has a neutral steering characteristic. When you turn your steering wheel, you get a nice, smooth response. So if you want to learn to race, you're going to find that this neutral steering characteristic in the Miata is the perfect way to learn racing. At YWen8698 writes, drove down I-40 earlier and hit a long and indistinguishable object fallen from the car in front of me. My car drifted at high speed for about 5 seconds. Wonder how autonomous vehicles will react to this. Autonomous vehicles need to react to unexpected situations on the road with skills that are as good as the very best human drivers. That was the reasoning behind building our autonomous drifting DeLorean, Marty. Marty is able to drift intentionally, putting the car sideways so that it's very, very controllable and it can track exactly the path that it wants, even in emergency situations. At ChorizoFan420 writes, you built a drift machine out of a DeLorean? Yes. So in the hands of an inexperienced driver, you're likely to over-rotate and spin out, but a skilled drifter can keep the car sideways and maneuver the car with pinpoint accuracy. This is what we were trying to do with our software. We've now largely achieved the ability to control the vehicle's path within a few centimeters while sideways. At Ween0 asks, why were cars back then more boxy and more curvy now? Older cars were certainly more boxy. They came from carriages. In the early days, would often be built upon a frame, and somebody else would build a body that went on top of it. At that time, there wasn't a lot of attention paid to aerodynamics or how lightweight a car body could be. In fact, if you went a little bit further, there still wasn't a lot of attention paid to aerodynamics, but more towards tail fins and what the car looked like. The size of the tail fins became an important marketing feature with new cars. So in the 1970s, there was a severe energy crisis, and that made manufacturers want to develop cars that were lighter weight and more fuel efficient. The way to make them lighter weight was to use unibody construction, design the car really as one unit. The way to save fuel was to make cars more aerodynamic. And that really changed the shape to the sleeker shapes that we associate with modern cars. In the future, one area that manufacturers are really looking at is removing the side mirrors, which create a fair amount of drag, and replacing these with cameras. At Kubek George asks, why are vehicles from the 70s outlasting vehicles from 2022? Cars in the 1970s had very few computers. With a reasonable set of tools, you could maintain that car then and continue to maintain that car today. The price that we pay for cars that are more fuel efficient and more environmentally friendly is that they've become more computerized. Cars increasingly have over-the-air software updates. Will you be able to continually update your software in the future? It's become impossible to do all of the work yourself on a modern vehicle. At Planetary Jim asks, why you put spoilers on race cars to make sure that they can grip the ground better. So if you think about an airplane, they generate so much lift that they can overcome the force of gravity and fly through the air. We can put something like an upside down airplane wing on the car, which is a spoiler. You can generate so much downforce with aerodynamics that you can overcome gravity. Imagine that I create a Formula One track upside down. If I get my car to run that way, my downforce becomes up force. It can actually stay stuck to this upside down track. Some people just attach something to the back of their Honda Civic to look cool. That's not an engineering thing, more of a styling choice. At Lumen Rio 1 asks, so you're telling me that if someone puts up a sign with the image of a green traffic light, it will confuse autonomous cars? Maybe. If it's using cameras to try to make sense of its current environment, it may very well be looking for traffic signals. If it finds one on the back of a semi and not actually signaling an intersection, it could get confused by that. One of the difficult things about programming autonomous cars is you have to think in advance about things that might confuse them. News reports from San Francisco show that people have been able to confuse Waymo cars by putting a cone on the hood of the car. That's something I doubt any engineer would have thought about when they were designing the automated vehicle. At Litter Picker Pro wonders, will cars of the future have wooden wheels? Can't get much greener than that. Are we going that direction in the future? No. But on the other hand, you may have tires that are coming from shrubbery. Bridgestone has been working with Wayul, which is a shrub that produces hypoallergenic latex. Tires could be biodegradable. We've paid a lot of attention to pollution from the tailpipe of cars. As tires wear out, they produce little bits of rubber and petroleum products that can actually cause health issues. At Mr. Xavier M writes, get at me. Ferrari versus Porsche. Both of these marques have tremendous racing history. On the Ferrari side, you've got that Italian styling, but I'm going to have to actually come down on the side of the German precision. If you want handling designed precisely to go where you're commanding with your steering and your throttle, it's hard to beat a Porsche. At Real Gritty Boy Zero asks, why does people getting crash when they have on Tesla autopilot? So psychologists know that if we don't have enough to do, our mind wanders, and it's hard to keep our attention on being ready to take control if we need to. Tesla's autopilot are level 2 automation systems. They require the human driver to be engaged and in control all the time. This is a challenge that the whole industry faces, and they're working on different solutions to warn or re-engage the driver. At EMVDN, self-driving cars running with AI present a new version of the trolley problem. How does the car make an ethical decision about who to kill by running over? So in one classic version of the trolley car problem, you're a bystander and you see a trolley headed towards 5 people on the track. You can switch to another track where only 1 is killed. Do you pull that switch? Automated vehicles have to consider situations where there may be loss of life, but they're not really using this sort of moral calculus. Part of my work with a safety advisor for Ford, I actually helped develop a set of rules that autonomous vehicles could use. And this just simply involves following the duty of care that the law outlines. Now, if other people violate their duty of care to the car by jumping in front of it when it doesn't have enough time to avoid a crash, you can program the autonomous vehicle to do the best it can, to do everything under its power to avoid that crash. Autonomous vehicles are out there protecting people who follow the rules and not making determinations about who's more worthy to live or die. At VAOD asks, if my self-driving car gets into an accident, why wouldn't whomever made the car be at fault? I wasn't driving. If a car is driving itself, the manufacturers will in general be liable for that. Mercedes has already made a very strong statement with their level 3 drive pilot that if it has a crash, the company is responsible and not the human driver. So we're shifting really into an entirely different world. In fact, in San Francisco, they've already run into the problem of how does a police officer give a ticket to an autonomous vehicle? That doesn't make sense when there's not a driver. At MBJ2042, why would I buy a hydrogen car when I could charge my electric vehicle at home? Think for a moment about over-the-road heavy trucks. In order to recharge them, they would actually need vast amounts of electrical charging capability if they wanted to do that in a reasonable period of time. They'd also have to carry massive amounts of batteries. Hydrogen may actually make sense for buses, over-the-road heavy trucks, probably not going to replace your electric vehicle and your charger at home. At Digital Blade CA wonders, if you had to solve real-world driving, would you go down the path of programming the rules of the road and expect the car to obey, or let a neural network learn to drive like an experienced Uber driver? You really want a combination of these techniques. So Tesla, they use neural networks to learn from their camera system and what the cars are likely to do around them. In contrast, Mercedes level 3 system tends to rely on rules. Engineers can program specific behaviors into the car to ensure that it follows the traffic laws or follows a vehicle at an appropriate distance. At Shoemeister asks, I'm really concerned about security when autonomous cars take over. What if they're hacked? Hacking is a real concern with automated vehicles, particularly those systems that can receive over-the-air software updates. There's also a threat as we move towards AI systems that hackers could get involved with the data stream. AI in an autonomous vehicle is trained by feeding it lots of data, which could be, for instance, a series of camera images. If you could hack that set of images, you could make it so that the vehicle failed to recognize certain objects in the environment, and that could create some serious safety risk. At Raverbruggen asks, why do cars have four wheels? Because we found out that is a really great combination to design vehicles that are stable, comfortable, and high performing. Motorcycles have two wheels, and it's up to the rider to balance. With a car, the suspension handles all of the balance. As my car goes around a corner, my tire forces increase on the outside and decrease on the inside to keep the car upright. If you have a three-wheel car, you actually have only two of those wheels helping to keep the car upright. And what this means is that the weight can shift very dramatically from one wheel to the other. These cars have a much greater tendency to roll over. At Mountain Dew MLG asks, why aren't we all driving electric cars by now? It's not a technology that makes sense for everybody. Range remains a limitation. If you want to take a long road trip, it is going to take you some time to stop and recharge your car. More time than it would take you to fill up a gasoline tank. So for many people, an electric vehicle is cheaper because they can plug it in at their home and use their own electricity. But if you have to charge your vehicle all the time at a commercial charging facility, you're likely not going to save that much money. At Dubai Future asks, will autonomous vehicles reduce the number of accidents? So autonomous vehicles will certainly eliminate some forms of human error. Autonomous vehicles don't text while driving. They don't drive impaired. They're never distracted because they can see 360 degrees around the vehicle. Autonomous vehicles won't eliminate all errors, but they will shift from the human driving errors to the programming errors. Over time, that should be a shift towards safer cars. So those are all the questions for today. Thanks for watching Automotive Support.